Now let me tell you what to do when you deal with a non-exact equation. So first of all, suppose you're given this wild equation. Let's first check if it's exact. Maybe there is hope. So let's do Py, which is 3xy plus y squared with respect to y. So 3x plus 2y. And then let's do Qx, which is x squared plus xy with respect to x, which gives you 2x plus y. Oh no, in this case, the equation is not exact. So what do we do? Well, first of all, it means that we cannot find an antiderivative, so definitely do not proceed. So what we can do now, we can either cry and question our lives, or it turns out sometimes we can multiply the ODE by a function to make it exact. So not always, but sometimes we can multiply an inexact ODE by a helper function, so also called an integrating factor. Integrating factor. To make it exact. So here, in fact, let's multiply this. So trick. So it turns out the helper function here is just a function x. So multiply the ODE by x. And by the way, you may wonder, yes, this will be given. So I will not ask you to find it because turns out it's beyond the scope of the course. To find that integrating factor, you actually have to solve a PDE, which is APMA 360. And so definitely nothing that you're required to do. But suppose I tell you multiply by x. Let's do that. So 3xy plus y squared dx plus x squared plus xy dy equals 0. So let's multiply all sides by x. XOXO, gossip girl. Okay, and then what we get is 3x squared y plus xy squared dx plus x cubed plus x squared y dy equals 0. And let's start over. So kind of like Groundhog Day. This is our new ODE. And let's check if this is exact. Again, check exact. So now let's do Py. Yes, so 3x squared y plus xy squared with respect to y. So 3x squared and then plus x times 2y. So 3x squared plus 2xy and then qy. Sorry, qx. It's quixotic, not quiotic. So x cubed plus x squared y with respect to x. So 3x squared plus 2xy. And in fact, we have a match, so we can proceed. So now let's find f. F, so again, like finding Nemo. So we have fx, which is p. which I want to remind you, don't use 3x squared plus 2xy. Use 3x squared y plus xy squared. So f is the integral of that 3x squared y plus xy squared with respect to x. So 3x squared becomes x cubed. And then x becomes 1/2 x squared, y squared, plus any function of y. And let's do same thing with fy. So that is x cubed plus x squared y. So once again, now we integrate with respect to y, x cubed plus x squared y dy. That becomes x cubed y plus, once again, 1/2 x squared y squared plus h of x, constant with respect to y. So what is our mystery function? Easier here, so you just compare x cubed y plus 1/2 x squared y squared. xy is x cubed y plus 1/2 x squared y squared. And so what is our solution? You just set that equal to c. X cubed y plus 1/2 x squared y squared equals to c. Now, big question that I get, before we multiply the equation by x, do we need to divide the solution by x? No. Because think of it as follows: if you play Super Mario, multiplying by x is like you using Yoshi to get to the next step, get to the next equation, and then you completely forget about Yoshi. You have this new equation that you deal with the same solution. So you don't need to divide by x in the end. So this is legitimately the solution of this. So really, moral of the story is, well, even if your equation is not exact, not all hope is lost. It's sometimes lost, but not always, because you can multiply an inexact equation by a helper function to make it exact sometimes.